All right. So far we've been talking about classes in terms of just like singular objects, right? Where we can have a book class, an author class, and a library class, and each of these are distinct and they do separate things. So while a book lives in a library, it's not like related to a library at all. It's its own separate thing, right? And so now we're going to talk a little bit about inheritance. So in programming, we're not talking about the kind of inheritance of like genetics, where you have some properties that you inherit from biological parents, like are your earlobes connected, or like do you have a widow's peak? And whether or not your parents have those affects whether you have those. So there's some properties that get inherited. And we're also not kind of talking about the sort of Scrooge McDuck kind of inheritance, where someone dies and then you get money or property. But there is things that are passed down. And so that's the kind of inheritance that we're talking about. And so our kind of inheritance is going to deal with code reuse, where we have some class that has properties and methods, these attributes and behaviors, and we're going to define other classes that will inherit those same things. And so the idea is we want to not have to type as much. We want to reduce the amount that we are just like copying and pasting. We don't want to do that. Instead, we want to reuse things and use inheritance so that it makes it easier for us to update and maintain the code that we have. And so what we're going to do is we're going to have some class that from which we inherit properties and behaviors. So for example, we've got a person up here. A person has fields including their name, their designation, and they have behaviors such as they can learn, they can walk, they can eat. And then we've got different types of people, where we've got a programmer who works at a company and does coding. So those are new properties and behaviors, new fields and methods that a programmer is able to do. For a dancer, maybe a dancer is part of a group and they can do dancing, but they can also do all of the person things. Like a programmer can learn, can walk, can eat. A dancer can also do those things, but also dances. And similarly, a singer can do all the things that a person can do, but also can sing and can play guitar. And so those are the inheritance part comes in where all of these three types of people, like they're still persons. And so we take those attributes and things that a person can do and we inherit them. And so we're going to talk about this relationship being like is A and is not A. And so, for example, let's draw a hierarchy of shapes. Okay. So first, so we're going to think of this relationship of like, let's see. So you know how like a rectangle and a square, they're related, right? They're both quadrilaterals. They have four sides, and each of them has a length and they have a width. So a square also has a length and it has a width, but the property for a square is just all of those are the same, right? And so we can say that a a rectangle is a square, right? A rectangle is a square, but is a square, no, I'm wrong. Is a rectangle a square? No. Is a square a rectangle? Yes. So because So for example, a square with side length of 1, it is a rectangle because it has 4 sides and it's got all right angles. But this quadrilateral is a rectangle, but it's not a square because the sides are not the same. So a square is a rectangle, but a rectangle is not necessarily a square. And we can have a circle as a shape as well. Let's say a rhombus. And then the thing that unites the rectangles, squares, and rhombuses are that they're all quadrilaterals, right? And we can keep going on. We can say like triangles, and there's different kind of triangles, like an isosceles, equilateral, depending on like how long the sides are or like what the angles are. We can write this sort of relationship. And the thing that ties them all together is that they are all shapes. So a quadrilateral is a shape and a circle is a shape. And so we're going to draw this sort of family tree of classes, where here's my family tree for a bunch of shapes. Here's my family tree for a bunch of people. And so we're gonna, so I've got the packet for this part of the unit as well. And so I've got 3 examples here. So car, Tesla, and vehicle, Tesla, and tractor, person, student, employee, soft drinks, and sodas and stuff like that. And so I would like you to get in your neighbor groups, the people who are sitting by, I'll come around with markers and put up on the board of what are these kind of relationships. And so the way that I'd like you to draw it is the more general things go to the top, the more specific things go to the bottom. So like over here, a quadrilateral, that's a super broad term. Quadrilateral means anything with 4 sides, whereas something like rectangle and square have more rules on them, like the angles have to be this way, the sides have to be this way. And so those are more specific. So the more specific things we draw towards the bottom, the more general things we draw towards the top. And we want to draw a line if we can say that this is a relationship holds. Clear on that? Okay. So I'll park the screen over here. I'll condense them. And I'll come around with markers. So group up and then draw your ideas on the board. All right. So we're gonna create our own hierarchy. That's the goal, where we want to create, so we've drawn this diagram, that's nice, of person, student, employee. And so we're gonna make that in code. So let's start with the person class. So I'm gonna go open Eclipse. I've got to open over here. Fun fact with the Plant UML plugin, so I can just like click on my pack. So I can click on any file in my package explorer and it'll show me the diagram for that class. If I click on the whole package, it gives me a bunch of things. So that's useful. So let's say if I wanted to save that, I can go right click on this diagram and say export, and then it'll pop up, where do you want to save it? What do you want to save it as? And so you can do that. That's useful for the homework. So once you have your package full of classes, then you just open it, the package in Plant UML, then you're good to go. But let's make a new class. I'll make a person class. Make this panel smaller. And so like for our example before, a person has what? A name. So string name. I could make them private. I'll just leave them package visible for now. What other things does a person in general have? Last name, which I think may fall under name. Height. How do we want to store that? Am I okay? So this could be like we can round up to the nearest int, or if we wanted to be super precise about it, we could go to a double. Height works. Person has an age, stuff like that. And so I'm not going to waste a whole lot of time. I'm going to right click, go to source, and then I'll generate a constructor using fields. All three of those fields is fine. And then I'll also grab my getters and setters. So I right click, source, generate getters and setters. And I'll do all three. Generate. All right, and so now I've got the basics maybe of my person class set up. And I think I'll do a toString just for fun as well. So I defined here are my three fields, and then I generated the constructor, the getters and setters, and the toString. And in lab 4, you played with this a little bit, but I'll just leave this as is. All right, that's my person class. Now let's say I want a student class, and like let's say we're going to think simple. A student has like a GPA, right? And so the goal is that I want my student to have all of the things that a person has and also a GPA. And so like a getter and setter for the GPA as well. And that's it. So one way I could do that is, oh, look, I'm in the person class. I have all this code. So let's make a student class. I'm going to make this, and then I'm going to delete it in a second. So I'm going to have a student class, and currently it's empty. So I'm going to go to person, and I'm going to copy everything within the brackets, paste it over here. And oh no, now I've got some things to change. So I can have like a double GPA. And then I need to add that to a constructor. And then I've got to add the getters and setters and so on. And so it's just like, for this simple class, there's 3-4 things that I have to change. If this class was way more complex, that would be a pain, right? Like I don't want to sit through this class and go through and change all the tiny little things and risk forgetting something that's super important, right? So copying and pasting, thumbs down. So when we have a person class, we want the easy way, but the way that we're not going to do it is through copy and paste. And this is because let's say we have some, like if we have some typo in our person class of like, maybe we capture an integer as the height, and for a student, for some reason, we want to measure like something else, the height as something else. And if we copy everything from person, we risk having some information that we didn't anticipate of if there's a typo or if something's wrong in the code that we copy, then it's garbage in, garbage out, where we copy garbage and then we paste garbage. that's also tricky for like maintenance and versioning. So later, if we want to change the format of some variable, like if we want to change the height format, then we've got to change that everywhere. So like if we have the height is an integer in person, and later we want to say, no, let's make that a double. Great, I've changed that in person. Now I need to go change it in student. And so now I need to go change that. That's a double. And then I also have to fix all of the getters. And that's just not fun. So the other thing about this is that the person in the student classes, even though they have pretty much the exact same code, there's no relationship to each other, right? There's similarities. The code is the same. They've got the same methods, but they're not related to each other. They don't have that line that we can draw of a student is a person. And so the way we do this is with the keyword extends, where we're going to set up this inheritance and say that this student is a person. And then we don't have to copy any of that code, where by making a student a person, it inherits. Here's the height, here's the name, here's the age. If we have like address, it inherits address. And all of those things that a person has, that a person can do, a student can also do as well, because a student is a person. And so the way we say that is with the extends keyword. So I'm going to delete this file because it's a mess. I'm going to change this back to an int so that we don't have errors. So I'm going to delete student. And then let's make another file. Okay, that didn't autofill again. So let's put us there. New class, there we go. Okay, so this is also the part of the unit where we start to learn what are all of these things that's going on here. So the name of my class is student. My superclass, so far we've had java.lang.object, which is the superclass of anything in Java. But now we're going to have it be something different because we want a student to be a person. And so if I click browse and then if I type person, so we can see that this is the type name that I wrote and it lives in this package and it lives in this project. So that's the one that I want. And so now the superclass is a person. Interfaces we'll ignore for now. All that other stuff we'll ignore for now. And finish. And now we say student extends person. So we're creating a student class and it will inherit all the things coming from person. Right away, we have an error. That's okay. The error in particular is implicit superconstructor person is undefined for default constructor, must define an explicit constructor. That's a lot of words. And so what it's saying is that we want to have, so in person, we say, here's how to set up a person. Here's how to create a person object. And in student, when we inherit, we need our own constructor. So we have an error without it. But, or we can have our double GPA as a field. That's great. And then let's make our getters and setters. So getters and setters for GPA. And so that's great. Now we just need to set up the person part of a student. And so I'm going to hover over this error and it's going to say add constructor student int. I don't know that I want that though. So if I click on that, it's going to give me the constructor for person. because person, so it says student int, or like, sorry, student string int. This is the string, the name. This is an int, the height. This is an int, the age. That's fine if that's how I want to construct a student. But if I want to construct a student with the GPA value as well, that's not going to cut it. So generate constructor using fields. Let's see. Yeah. Okay, so remember back in combo lock when, let me open that one up. So, all right. So I don't have that in here. But in combo lock, when we had our 3-parameter constructor to set up the 3 numbers, instead of doing something like this, we could have said this and then just give it 0, 0, 0. It's the same thing, where this is referring to our current object, and we can call our constructor to say, we call this like the combo lock in constructor with 3 numbers. And so it's this similar kind of thinking where we're going to have a call to super, so the super class, the class above us, the person, and we're giving it, here are the things that a person cares about. I'm going to leave it to you to set up because I have code to do that somewhere else. So giving it super of name, height, and age passes it to here to construct the person part of the object so that we in student don't have to worry about it. That's our goal. We don't want to worry about stuff that we don't have to. And so when we can, we're going to hand it over to person. And so once we define our constructor and we include that call to super, then we're good. We can save the file and the error goes away. All right. So in the process of doing that, we've added a new field. So a student has a new field, the GPA. We can add new methods. So we can add like get GPA and set GPA are methods that didn't exist to a person, right? A person doesn't care about GPA in general. A student cares about GPA. And we can also override existing methods. So let's write a demo, a driver file to kind of test this. So new class, I'll call it people demo and give it a name. I'm not changing the superclass because I don't want people demo to be a student or a person. I just want it to be a scripting file where I can test things. So I'm leaving the superclass normal. And so let's see, well, we can have a person. Their name is A. They are 12 inches tall. And let's say they're 3 years old. And we need the new keyword. And then we'll have student. And how tall should student be? Let's see. Okay, let's say our student is 60 inches tall and 18 years old. And so if we do that, then it says the constructor is undefined because for a student, we also need to give them their GPA. And so let's make B a very good student. They have a 4.0 GPA. Hooray. And so if I print A, and if I print B, I'm going to print a person and then printing a student object. So if we do that, oh no, they're both people. And so what happens is the toString method is inherited. So we didn't define it in, so we did define it in person. And this is one of the things where you'll notice that if we don't define a toString method, so like if we comment this out and then we run this again, it prints that information. And so that comes from the java.lang.object. That's the superclass. And so when we don't define a method that the superclass has, when we don't override it, it just inherits unchanged. And so that's what happens if we take out the toString. But we can override toString in student. So we've overridden it in person. And we can also override it in student. So let's just generate the boilerplate one fields GPA. And now when we run our demo, now it prints that's a person, that's a student. So we can override and say, I don't want that sort of, like, I don't want to print all that information for a student. For a student, I just want to print their GPA. So that's saying, don't print that anymore, print this instead. So this is kind of like, let's think of an example. So like, for the soft drinks, for like the Sprite and Coca-Cola, like they have flavors. And so they may print those flavors, or like they may print the artificial colorings that go in there. Whereas the water-based drinks just don't bother because they don't have it. So we want to print the information that's useful for us in this moment. So we can override existing methods. We cannot remove fields. So as a student, we can't decide that we don't have a name anymore. We can't decide that we don't have an age anymore. So those attributes are inherited. We can't remove methods. So we can't say, I don't want you to be able to get my height. Like, you're going to be able to do that anyway. So we can't remove fields. We can't remove methods that are present in the superclass. And as we saw, we get an error. And so the new class must specify its own constructors. Let's take a look at this. So take a second and maybe turn with your neighbor and make an employee class that extends the person class, and just do the source generate getters and setters as needed. And think what additional fields or what additional methods make sense for an employee. Just talk with your neighbors. Go for it. All right, so I won't do it. I'll just make the class. So new class, and then the name is employee, and the superclass, I can hit browse, and then I can go to person. And then hit enter, finish, and there we go. And so now I can be like, okay, what does it make sense for an employee to have? Maybe they have a wage, maybe they have a string of their occupation. Any other ideas that you had? Say that again? No. Cool. So that's fine. So yeah, so an employee extends a person. Employee is a person. And so the way that inheritance works is, let's say we have private fields. So let's say in person that these fields are, instead of public, they're private. And so I'm going to do that multi-line selecting thing. So that's an edit toggle block selection. And so we'll draw over there. And I'll make them private. Edit toggle block selection, back to normal. And so let's say that they're private in person, which makes sense because it's a good habit for fields to be private unless we need them to be otherwise. And so now we've got maybe a problem where maybe we want to print their name as well, to say, here's my name, here's my GPA. But the problem, if I make it private in person, right? For private things, we can only access it within this class. So only things in person can directly access the name field. Otherwise, we need to use getName. And so we can't directly access it in student. Does that mean it's gone? Like, goodbye name? A student doesn't have a name anymore because it's private. No. So the problem here is the field person.name is not visible. And so we can get it in other ways. So a student is still a person. And a person has a method getName. And so we can just call that instead. And so the thing with getName is public. And so that's visible. We can grab that. So even if we make things private in person, it means they're not directly accessible in student. But that doesn't mean that they're not present. So we can call the method getName and still retrieve that information. And it just means that we can't directly call the name field. And so this we see before we implement toString is if we have a method in person and it's not redefined in student, then we inherit it unchanged. And so if we don't define toString in student, it's just going to give us the toString for a person because a student is a person. And so it'll give us that information if we haven't said do something different. And so the question is, if we have a constructor in person, does that mean that we don't need one in student? The answer is no. So student has to specify its own constructor. So I've got an error in employee currently because I don't have a constructor. So I need a constructor here. So I will just set one up here. So it will stop giving me an error. So yeah, so in our subclass, we need to specify our own constructor. All right, so if we have a method in person and we redefine it in student, great, we can do that. So that's toString. Let's say we have something that we're overriding and we want to make, so let's say in students, we want to override getName. So public, and then name is a string. And we say getName. And so we can say, does this work? It does. And so we can call the old version of getName and just add on that, hey, we're a student here. So we'll talk about partial overriding in a little bit. That's what this is, where we're doing what our superclass does, just a little bit more. So we're still, if our name is John Doe, and then we're just adding student, John Doe. So let's check that this works. So name is student B, and so that's where get name, because we call get name and student in the toString. And so that works. So we've done this partial overriding. But let's say I want to say that nobody can get my name if I am a student. So we can try and make it private, but we get an error, cannot reduce the visibility of the inherited method from person. And so what this tells us is that if we try and override something, we cannot reduce visibility. So if something was public in person, it has to be public in student. So we'll change that back to public. So can we overwrite something in student and lessen visibility? No. Can we add methods to student that weren't in person? Yeah, because we can get GPA, set GPA. Those are methods that a person didn't care about. And so a student is still a person. And so let's write a method that tries to be a little generic. So we'll talk about genericity in 2-3 weeks. But we'll give it a shot now. And so I want to write a method for if I've got two people, which one is older? So we'll go to my demo file and I'll write a method. It'll be a static method because do I want to create a people demo object? No. So this is just for scripting. This is my demo, my driver file. And I'm not quite sure what my return type is. And so I'm going to take person P1, person P2 as my parameters. And so maybe I want to check, so if person P1 is older than person P2, and false otherwise. So I'll return a Boolean. So if I'm giving it a 3-year-old and an 18-year-old, that would be false. If I'm giving it an 18-year-old and a 3-year-old, then it would be true. Right, so the order here matters. And so this is fairly simple, p1.getAge. If that's greater than p2.getAge, then this is true and will return true. If P1's age is less than or equal to P2, the second person, then it'll return false. Okay, so if we go down here and we say, so let's print the result of this, of is older, and our person 1 is A, and person 1 is B. If person A is 3 years old and person B is 18 years old, what's my is older gonna return? False. Because is 3 greater than 18? No. Okay, so I would expect this to print false. My first question is this gonna work? Because My variable A is a person. My variable B is a student. I mean, a person is not a student. A student is a person, but like there are different types. Okay, who votes that this won't work? Show of hands. Okay, at least one person votes it won't work. Who votes it will work? Okay, let's see. It did work. Why? Yeah. Yeah, a student is a person. And so as long as we're asking for things that a person knows, asking for things that a person has, we can do this. We can say that, yeah, B may be a student, but B also has an age. And so we can get that and compare it. So this is type compatibility, where we reduce the possibility for methods like a person. So person, that's fine. We don't need to make a person-student method or a student-employee method. As long as we're asking for something that all of these types has access to. So as long as we're asking for like age, which is something that a person has, we can refer to them by a person reference. And so that's what allows us to do this. And so this helps make it more generic and helps us to future-proof it. So like if we're asking to compare the age of a student and an employee, we can do that. Okay, let's see what that question is. Number 4. All right, problem 3, I'll leave for you at home. Problem 4, I will also leave for you at home at the moment. All right, so we have to talk about terminologies a little bit. So far you've heard me call it superclass and subclass. So if we're talking about a person and a student, the more general thing, the thing we drew on top, that's the superclass. The more specific thing that we draw on the bottom is the subclass. And similarly, we can call person the base class and student the derived class. All right, so you will see superclass and subclass, especially in Eclipse. You might hear me talk about base class and derived class. They mean the same thing. So the idea is the more general thing is the superclass, it's the base class. The more specific thing is the subclass and the derived class. And so if you want the subclass to have some direct access to something that's private, so like if we want our student to directly access their name field, that's an option. This is one of the visibility options that we kind of skipped over and said we'll talk about it later. It's later. Hooray. Now is the time. So one option is to make that field public or package visible. And so for us, that would work because like student and employee currently both live in the same package. So making it package visible would be okay. We can also make it protected, which means both it's package visible and it's accessible to every class that derives this one. So even if I have something that extends person living in another package, it can still directly access its name. So that's what protected means. So it's package visible plus it extends throughout the hierarchy. So for example, let's choose one of the Yeah. Um, and it's also hard because like what are the properties of a beverage? Um, like I don't know, the size of the beverage, the amount of like milliliters or something. Uh, and so if all of these, because it for the beverage hierarchy, they're kind of all over the place. And so we'll probably want to put them in different packages. But for beverage, if we make that field protected, then all the things in the different packages can still access that field directly. So yeah, so it makes it directly visible to the things in this package and any subclasses, no matter where they live. All right, so this is that visibility summary again, where private means only within this file, public means anyone, anywhere. Package means only things in this folder. Protected is kind of a mix where we can access it inside the class. We can access it inside the package. We can access it inside the subclass, but apart from that, if you're not related to this class, you're out of luck. All right. So every derived class, every subclass has to specify its own constructors. So everyone gets their own. As usual, if none are provided, then that default, remember with int cell when we didn't specify the constructor, the zero parameter default, the compiler like adds that in and it'll just give you all zero, false, or null. And the way that the constructor works is you first work on what's inherited. So for a student, first you build the person part of it. And so the call to super helps us get that done. That's got to be used in the first line. And if you don't provide it, it'll still do it automatically. Let's test that. Okay, so maybe that slide's wrong. Where if I comment this out, or if I comment out my super, then it's not happy with me. So implicit super constructor is undefined. Sorry, my voice is going. Right. So we need our own constructor. So another option is final, where so currently either our derived class overrides something or it accepts it unchanged. But there could be a possibility where we don't want someone to override it later. And so we'll see this, we're going to have a shape hierarchy, and a shape is going to have like, let's see, semi-perimeter, where a semi-perimeter is just like half of the perimeter. And we know what semi-perimeter is going to be. It's always half of perimeter. And so it doesn't make sense to to run the risk of someone else changing what that means. And so when we don't want someone to override this later, we make it final. And so a final method means that we cannot override it by any subclass. Another way of saying this is that its definition is invariant. And so we always are going to know what this method does. We can also make a class final if we wanted to. And so that says that this class cannot be extended. Trivial setters and getters are generally good candidates. And so to make something final, we would have it be something like, so final goes between the visibility and the return type. And so we can like make all of these final. One question you might get on your exam is if a class has all final methods, is the class itself final? So a class being final meaning we cannot extend it. If a class has all final methods, is that the same as the class itself being final? Turn to your neighbor, talk about it. Yeah, and why not? Yeah, so it's not final, right? Like a class being final doesn't mean, so sorry. A class with all final methods doesn't mean that the class itself is final. Because even if all the methods are final, we can still extend it. If a class is final, we cannot extend it. All right, we saw partial overriding. That's over here. So we can call like, hey, superclass, run your get name method, please. We also don't have to say super dot. We could just say get name. That's also partial overriding. Let's test if that works. No, it's not partial overriding. I have in fact done recursion. So, okay, I was wrong. Turns out you do need super. So yeah, what happens here is that I ask, hey, please give me your name, student. And the student's like, okay, it's going to be student plus whatever get name is. And so now I'm back here at the top of get name and ask, okay, student plus whatever get name is. And this continues forever, or not forever, until the compiler is like, yeah, no, we're done here. And so that's the Stack Overflow error where we've gone too far. So we need to be specific about this. So we have to say, superclass, please give me your version of name so that I don't go around in circles forever. And so when that we've got that, then we're good. Okay. Type compatibility, the thing we talked about for methods, also works for like arrays. So if we've got, if we want to have an employee array, we could create it as a person array if we wanted to. But then we can't like put a student in there. Maybe. Let's test it. So we're going to have an array of persons. And maybe we'll have 10 employees in there. The question is, can we assign B into that spot? So the idea is kind of we've got this array and we're like, great, persons are going to go in there. And then on the right-hand side of that declaration, we are allocating and we're saying each thing is going to be an employee, that's going to be an employee, that's going to be an employee. And this could be on purpose, right? We could have an array of employees that at some point we want to refer to by a person reference. And so this line, I think I can argue that it could make sense in certain situations. But the question is, could we put a student in one of those spots? Who votes for yes? This will work. No votes for yes. Who votes for no? Okay, let's test. No. And the exception is array store exception, which I believe is because we have tried to put a student in an employee spot, and it's like student, employee. No, we can't do that. However, if we said this is a person, who votes for yes now? Okay, who votes for no still? Okay, so that one works. And instead, if we said it was a student, who votes for yes? Who votes for no? Right, this makes sense because we've set aside, here's a spot for a student, and we're giving it a student. So yeah, so as is, no, that doesn't work. Let's see what problem 9 is. Right, we did that. Hooray. All right, and so it's important to make sure that things are type compatible in general. So for lab 5, you're going to have this like company that you're building objects for of different types of employees. So we've got hourly employees, salaried employees, and we need to make sure that both of those are going to be compatible with employee in general. All right, let's talk about abstract classes. This is the fun part. So if you've still got your whiteboard marker, so yeah, so let's go back to the boards and draw really quickly a hierarchy of shapes. So I drew a version in the beginning, and so think of other shapes. Like, what about an octagon or like a sphere or something like that? So draw some hierarchy of shapes. Go for it. All right, so the hierarchy that I'm going to draw is going to be much more simplified than the ones that you have drawn, where I'm going to consider a rectangle and a square and a circle. Okay, so that's my much more simplified hierarchy. And so I want to create, so that's fine. I can create a rectangle class. I can create a circle class. I can create square, which extends rectangle. And I can even make a shape class. So I'm going to do this same thing where I'm modeling bad behavior. I'm going to make a shape class that I'm going to delete in a second. So let's make a new class. I'm going to put it in a new package. So, but I'm going to make it a subfolder of my unit 4 ones. So I'm going to do that with dot shapes. And I'm going to make a shape type. And this is the goal for the shape is to be the highest thing in my family tree, right? Shape is the most general thing. I'm going to have a shape, finish. And so thinking about a shape, like what are the properties that I care about? So maybe we could take the polygon route of like a circle is an infinitely sized polygon. But a circle is defined by other things. So like a rectangle is defined by what are its length, what's its width. A circle is defined by its radius. So like it's kind of apples to oranges, right? I don't want to make them united in that way in code. And so instead, I want to have a more general type that links it all together. But like, what do I choose? What fields do I choose that unites all shapes together? I don't know. That's a lot. And so maybe I don't have shape fields, but I could have methods. And so like a shape has so like length and width don't make sense for a circle, but both of them have perimeter. Both of them have area. So I can do that. And so maybe I can make them fields, but I'll just make them methods because we want to be able to like calculate. Just because the idea is I want to reduce the amount of work that I have for myself when I go and write my rectangle, square, circle code. I want to do as much as I can now in shape. And so I'll have perimeter, and this will probably be a double. And what's the perimeter of a general shape? I don't know. So I don't know, maybe like leave it to you later. If you get -1, then that's your sign that you need to fix this. You need to override it. We can have public, and similarly for area, like what's the area of a general shape? I have no idea. And so we'll have the same thing. This is like what I talked about earlier. This is a good candidate for a final method because if I know the perimeter, so like I can call this dot perimeter divided by 2 and return that. So even if it's -1, it's still going to work. It's just going to be the -1 divided by 2, -1/2. And so I can make that a final method because the semi-perimeter definition is never going to change. Like it's always going to be 1/2 of whatever our perimeter is, whatever that means for the specific shape that we're looking at. So this is my idea for this general shape. However, there are problems. The problem being, I'm relying on me in the future, or if I'm working on a bigger project, I'm relying on some other developer later on to fix problems that I have created. Because I've said, so I say -1 to like set a flag, but what if they forget? Like, there's nothing preventing them from just inheriting perimeter and just going along with their day, right? I don't force them to say you have to redefine perimeter, you have to redefine area. I'm not doing that in this code. And that's a problem. So returning -1, we can risk it not being overridden. The way we make it, the way we force the user, me or someone else, to override this method later is we make this method abstract. And so when we make a method abstract, that means all derived classes, all subclasses, so every shape has to implement this method eventually. So maybe they don't have to implement it right now, but some subclasses do. Something being abstract means that the method we do not provide default implementation. So it's just going to be method signature semicolon. So we're not going to provide any implementation, and we're just going to say, this is a method I need you to implement, and move on. And so what that looks like, we add the abstract word, and then we can delete the brackets because abstract methods do not have any default implementation, then this is what our method signature looks like. We just have visibility. It is abstract. Here's the return type. Here's the name of the method. Here's any parameters. We're done. Any subclass has to implement this. I have some errors currently because if a class has an abstract method, it has to be abstract itself. And so if we think about it, like, do we want to construct a general shape object? Like, does it make sense to have a shape object in code? We've got methods, but like, I don't know what perimeter is for a generic shape. I don't know what area is for a generic shape. So I don't really want to create a shape object. You'll see this in the lab where the lab has different kinds of employees, hourly employee, salaried employee, like temp workers, stuff like that. And they're joined by this general employee type. And we're never going to make just like a general employee type, right? It's too generic for our purposes. We don't necessarily want to make a soft drink object in code because when we go to the store, we don't go and like, oh, soft drink, I will buy that. We go, oh, I want a Sprite, or oh, I want a Dr. Pepper. Like we go for the specific objects and not this general generic kind of thing. We're buying a specific object at the grocery store. And so to be able to have abstract methods, the class needs to be abstract itself. And so we add that word public abstract class shape. And so I'll show you what that would look like if we were to just like create this. So that's my type name. And oh, look, here's modifiers. So like we can say this class is going to be public visible or package visible. And it could be abstract, maybe. And so if we check that box, then when we go through the process, it's going to give us the abstract word typed there. Okay, let's make area abstract. So no curly brackets for abstract methods, just method signature, semicolon. Right, so the class that has at least one method is an abstract class. We don't need to have all abstract methods. In fact, we don't here. That's not an abstract method. That's fine. But we do have at least one. And since we have at least one, this class has got to be abstract. All right, let's see what number 10 is on the worksheet. Does an abstract method have code in it? No. Does an abstract method need curly brackets? No. There's no curly brackets, there's no code inside. No curly brackets, no code. Can we make an object? Can we construct a class if it has only one of the abstract methods? Like if only one of the methods is abstract, can we get away with it? No, because so let's think about for a second if we tried. So I've got this idea of a soft drink, and one of the methods is abstract. I can't like create an object, like I can't create like a soft drink object. And there's just like one of those like it doesn't make sense. Like I can't create a shape that I don't know how to run a method for, right? To create an object, I need to know here's what to do for every method for every field. And if one of those is abstract, then that's just like a big question mark. I don't know. All right, I might ask this one on an exam. The word used to make something abstract is abstractify. Thumbs up for true, thumbs down for false. Thumbs down. Exactly. What is the key word to make something abstract? Abstract. Great. All right. So in summary, we have some kinds of class methods. We've got final methods. Those are ones that the method is invariant over the class hierarchy, meaning that we're defining it here. Its implementation will never change. I will never want to override how this method works. We have abstract methods where the base class provides no implementation, but derived classes are required to either provide that or be abstract themselves. We'll see this in the lab, where we have, I believe, let's say we have employee and we have hourly. And so hourly is temp and one other thing that I'm forgetting at the moment. And so the idea with employee, like employee is going to be abstract because that's too general. I don't want to make an employee object. There's more specific things. But also hourly, while it's a little bit more specific of this is a kind of employee, it doesn't make sense to create an hourly employee object. I want to be more specific. So there's a temp employee and the other thing that I'm currently forgetting. If a method is static, then it doesn't have a controlling object. So we're not going to make a people demo object. And then other methods is pretty much anything else. So we're going to provide this default implementation. And then when we extend to this class, it's either overridden or, yeah, sure, fine, I'll take it. All right. All right, let's make a rectangle. So I'm going to make a rectangle and my superclass is going to be shape. Oh, look, here's other checkboxes. Then now we kind of know what is going on. So one of them is public static void main, which we've been using so far. Other is constructors from superclass. So if we want to bring those in without having to go hunt them down ourselves. The other is inherited abstract methods. And so the methods that are abstract in our superclass that we need to implement, we can check this box and it'll bring them down for us. So if we do that, then they show up to say, hey, I'm overriding this method. You need to implement perimeter. You need to implement area for you to be a valid shape. If I choose to not, so let's say I don't have one of those, then my class is going to give me an error and it says the type rectangle must implement the inherited abstract method shape.perimeter. So it's like, you're not abstract and I need you to implement perimeter. And so I've got two options. These options, sometimes the quick fixes aren't useful. In this case, they absolutely are. To say that Either we add the method that we don't have, or we make rectangle abstract. Those are our two options. So I'll put that back. And so for a rectangle, the fields, the things that we care about, is going to be something like length and width. I absolutely do not recommend you naming these variables L and W, mostly for the lonely L, because that is so easy to compare to like a 1, or like the typeface kind of makes it distinguishable, but it's so easy to miss that. So don't name your variable single letters. So then what's a perimeter of a rectangle? Like length times width, or length plus width plus length plus width. And so, yeah. Great. And then area is length times width. And great. We can do that. And now we have a concrete rectangle class. We also probably want to have a constructor. So I'll source, generate constructor from fields. And now we have a constructor that just takes in the length and width and says, here's what they are. Let's look at the UML diagram. So we've got our rectangle. They're package visible, but that's okay. Perimeter, area, rectangle. That's our constructor. We can also see our abstract class, shape. And so, can I zoom in? Very slowly. And so shape, there's shape, there's this like double line, which makes sense because we don't have any fields. So that's where the fields would go if there were any. But it's different. Oh, why is it scrolling for me? I don't know. It's different because we've got why is it doing this? We've got an A instead of a C. So this blue A means this class is abstract. A for abstract. C for regular old class. And we've got abstract methods. So we know we made them abstract. And so they're italicized, which means that they're abstract. So italicized is abstract, but otherwise they look like regular methods, right? They've got a name, perimeter, and double. That's the return type. We've got, for area, it's an abstract method, so it's italicized, and it still has a return type of double. And then we've got semi-perimeter, which is not italicized, so it's not abstract. We go back to shape. There's no abstract word here. And so, come back. So yeah, and so that's fine. And so we've drawn this arrow to say that rectangle is a shape. And so if we write other classes, we'll find that if we write a circle is a shape. Let's do that really quickly so we can see it. So my type is circle. I want to make like an actual circle. I want to give a circle a radius. So I'm not going to make it abstract, but its superclass will be shape. And so the main defining property of a shape is how big it is, like what's its radius. So we can say that's the radius. And then the perimeter of, well, okay. Okay, so I know the area is pi r squared. So we could do radius times radius, or we could do math.pow, which if I read this very small text, says returns the value of the first argument raised to the power of the second argument. And so if I want to have the radius squared, I have radius raised to the power of 2. All right. We'll finish this next time. We will also look at interfaces. So we didn't quite get as far as I'd liked, but we'll finish this on Tuesday and then get into lab 5. Thank you for coming. See you next week.